Hi there, welcome back to the Back to Basics series. So, you have decided to dive into electronics. You're watching tutorials, you're looking at schematics, but then you hit the wall. What tools do I actually need, and where do I start without spending a fortune? That's the biggest barrier for everyone. Today, we are building our first electronics workbench. We are going to break down the 6 most essential pieces of gear, from the absolute must-have to the powerful diagnostic equipment you will eventually crave. I'm structuring this into 3 simple tiers to make it progressive. Tier 1, the must-haves, which are the stuff you need on day 1 to even build a circuit. Tier 2, the essential builder stuff, or how to make your project permanent. And Tier 3, the diagnostic duo, or how to troubleshoot and see signals you can't see with your eyes. That's for when you need to actually see the electricity doing its things. Let's start building. Let's dive into Tier 1, the prototyping pair. First up, the breadboard, your best friend for starting out. It's basically a temporary solderless slab. It will let you try things out, make mistakes, swap components, basically super fast iteration. The key thing to get though is how it's wired internally. Those middle columns, they connect vertically, little strips of metal inside. You plug your component legs into different rows in the same column, and they are connected. Those long strips on the sides, the power rails, run horizontally all the way from left to right. Knowing the difference saves hours of confusion, so vertical columns for components in the middle, horizontal rows for power on the sides. Simple when you know it. Let's build a classic, an LED circuit. We'll drop the LED and a current limiting resistor right here, connecting them together with this jumper wire and finally connecting the power rails to our power supply. See? Instant light. No soldering needed, and if the LED doesn't light up, I can instantly swap the polarity. And once you've built something, you need to check if it actually works or why it doesn't. Which brings us to the second must-have in Tier 1, the digital multimeter or DMM. The Swiss Army knife. You just can't debug what you can't measure. It's fundamental. Safety too. Measures voltages, current, resistance, the basics. Let's check how it works. And let's start by checking the voltage of a standard AA battery. I have set the DMM to measure DC voltage. We attach the red probe to the positive terminal and the black probe to the negative. This battery is supposed to be 1.5 volts and look, it's reading a very close value. This is how to confirm if your power source is alive. Let's now measure a common resistor and show the difference between the market value and the actual value. Switching to the ohm symbol for resistance, I have a 1K resistor here. See what the meter is reading? Yeah, close enough. Always remember that tolerance means the market value is just the target, not the exact value of the component. Here is a pro tip. Don't just focus on measuring resistance values. The continuity mode is often way more useful for beginners. It's essentially a beeper. That simple beep tells you instantly if you have a complete connection between 2 points, or, crucially, if a wire is broken inside the insulation where you can't see it. It basically confirms that your connection paths are good. Way faster than trying to measure near zero resistance. Beep means connected, no beep means broken. Very simple. Let's now move on Tier 2, the essential builder. So, your breadboard circuit works perfectly. Awesome. But now you want to make it permanent. Put it on a proper PCB or maybe a perf board. And that means soldering. You need a soldering iron and you need solder. This is where things get hands-on. But what iron to use? There are so many types. The key thing is temperature control. You need to be able to set the right temperature for your soldering components. Too cold and you obtain bad joints. Too hot and you damage the components. And then you need the proper technique. This is where people often mess up, big time. The absolute number one rule is melt the solder with the components to attach together, not with the solder tip. You touch the hot iron tip to both the component leg and the copper pad on the board at the same time. You hold it there for a couple of seconds, just long enough for them both to get hot. Then you touch the solder wire to the joint, not to the iron tip, and the heat from the pad and the leg melts the solder, making it flow nicely around them. You're aiming for that classic shiny volcano shape, a little cone, not a dull blob. Definitely not a dull blob. Dull or lumpy means a cold joint, which will probably fail later. Also, always use a fan or work in a well-ventilated area. Those fumes aren't good for you. Now let's talk about Tier 3, the diagnostic duo. This sounds more serious, well it is in a way. This is for when you move beyond simple DC circuits into things that change over time, like audio signals or digital signals. First in the list is the function generator, or the signal injector. Its job is basically to create predictable electrical signals. Non-clean waveforms, usually sine waves for analog stuff, square waves for digital, and maybe triangular waves in other cases. Why is that necessary? Can't I just use the signal from, say, my phone's headphone jack? I could, but is that perfectly clean? Does it have noise? Is its amplitude exactly what I think? A function generator gives us a reliable, known, good input, and so you are eliminating all the unknown variables. If you test a filter circuit with a perfect sine wave from the generator, and the output looks wrong, then you know the problem is in your circuit, not just some garbage coming in. It's about a controlled testing. And now, the function generator partner, the oscilloscope, the big gun. This is arguably the most powerful debugging tool in electronics. It lets you see electricity. It draws graphs, voltage on the vertical axis and time on the horizontal, so you can see exactly how a signal changes millisecond by millisecond, or even faster. So you can see noise, distortion, timing glitches, things way too fast for a DMM. And the key to using it effectively, the thing that unlocks its power, is the trigger control. It just tells the scope when to start drawing the waveform on the screen. It looks for a specific voltage level on the signal, so every time the signal hits, say, that particular level, while rising, the scope starts drawing from that exact point. And because it starts drawing at the same point on the waveform over and over again, that fast-moving signal looks like it's standing perfectly still on the screen and makes analysis possible. So, you hook the function generator output, like a 1 kHz sine wave for example, to your circuit input, and then you probe the output with your oscilloscope. And you can see precisely how your circuit affects that signal, stable and clear, thanks to the trigger. That's how professionals diagnose high-speed problems. Okay, let's recap quickly by function. Tier 1, the must-haves for prototyping, are the breadboard and the DMM or digital multimeter. Tier 2, the essential builder for making it permanent, is the soldering iron and the solder. And Tier 3, the diagnostic duo for seeing the unseen signals, are the function generator and the oscilloscope. That's the core toolkit for your lab. The really crucial takeaway is that you don't need everything on day one. It's scalable. Start with Tier 1. Get comfortable prototyping. Then, when your projects demand permanence, you move to Tier 2. And only when you're dealing with signals where timing and shape really matter, like building an audio filter or maybe something with a microcontroller, you invest in Tier 3 for that deeper diagnostic view. So start small, build your own skills, and let your projects guide how you grow your lab. Build it organically. You don't need everything at once. Let me know in the comments which of these tools was the first one you bought. And don't forget to like this video and subscribe to the channel. In the next video of the series we will dive into our first components, what they are and how they work. I'll see you in the next episode, and in the meantime, happy experiments!